What's the answer to number 1? Everybody okay with that? Okay, what about number 2?
X squared plus y squared.
And number 3?
Every day y over x.
Perfect. Now let's look at the next quiz. We started talking about this yesterday. Let's use this problem as a jumping off point. Change into polar form. Now, can anybody remember, or do you have it in your notes, what do we mean by polar form? What is that going to look like? Polar form. Tom?
You want the r, you want to get the r value and the degree value.
And what do I do with them once I get them? What does the answer look like? I need r and theta, but what does it look like?
Oh, isn't it like r cosine theta?
Close.
Plus sine theta or something.
Remember that from yesterday?
Oh, okay.
Longhand form was cosine plus I sine. Someone act like you've seen
Oh,
that
yeah,
before.
we saw it yesterday.
We did see that yesterday,
Yeah.
That should be in your notes somewhere. This is called, okay, this is the shorthand, this is the longhand, and this is called the polar form, or also the trigonometric form.
Well, I'll filter it most of that.
So either one of those means this. So like Tom said, we have to take this number, and we somehow have to find r and theta. We already know how to do that, right? So we'll draw a picture. Over 2, down 3, because this is x plus yi. What do we call a number in this form? What's this form called? Standard? Cartesian? Complex? Rectangular. All those words describe this. Okay. All right, so what's my radius? 13. And then I'm going to figure out the angle. Right? What'd you get for this little angle right here? 56.3. Are you with me on that? And this then is your theta, though. Do not put 56 in there as the answer. Theta would actually be 303.7. Anybody have a question about that? Everybody gets where those
That's the
numbers
final
come
answer.
from.
That's what we put right
That's
there.
the final answer. Or I use the shorthand. If you wanted to write it out longhand, you could do that too. Number 2 on this quiz down at the bottom. Number 2. The answer is 8. Remember, if the coefficient on theta is even, it's double that number. Change 4 100 degrees into rectangular coordinates. Okay, now what does that mean? What am I looking for?
I mean, so you already have 4 cosine I sine.
No, I'm not doing this. This would be polar form. I want rectangular coordinates. Coordinates means an ordered pair. What does rectangular mean? I am looking for x and y. Okay, let me say this again. Coordinates means ordered pair. Okay? Rectangular means x and y. So we got to find x and y.
Well,
What did you say, Katie?
X for cosine 100, y for sine.
Yeah. How do you find x and y? You find x and y by using your little conversion formulas. At least That's the easiest way to do it. There are other ways. But the easiest thing to do is to say x equals 4 cosine and y equals 4 sine. And then we just go to our calculator and we type that in. So about negative 0.7 and 3.94. Okay. Now that last one is what we're going to learn how to do today. So let's hang on to that one for a minute. Just leave that paper out. We're going to come back and do that problem. We have a couple other things we want to do here to practice a little bit more. Okay. So let's right now change this in the polar form. Harry,
Miss Ford?
you're irritating me.
I'm very sorry.
All right, I'm going to change this into polar form. Let's see what my dear friend Miss O'Brien gave me. I'm going to wear this proudly. You know this is a big year, right? For Pi Day, 3.1415. That only happens, once a century. Well, we'll celebrate on Friday.
What about?
Oh, it's on Saturday. That's crazy.
And wait, what about at like 9:23 a.m.?
Well, that's on Saturday.
I'm telling my kids about
I'm
this.
gonna do something special on Saturday, but I haven't decided what yet. Okay, we're gonna change this into polar form. All right, what does that mean? Well, it certainly involves r and theta, but what do I do with the r and the theta? You got two choices. You're either going to write an ordered pair, or you're going to write this. That's what we do with r and theta. Those are our two choices. Same r, same theta, but it's just a matter of whether I write it this way or this way. Which one?
Top.
The top? This one. This is what I want. You guys, right now, I need you to focus. Polar form means RCIS theta. That is also trigonometric form. When you see either of those two words, this is what you think of. Okay? Period. If you see polar coordinates, this is what you think of, an ordered pair. Same r, same theta, but you either write it with your CIS notation or you write it in parentheses. Now, this says, take this number and put it in polar form, so that's my goal. Now, I'm going to find r and theta. We know how to do that, right? What do we do to find r and theta?
Oh, make the triangle.
Draw a picture of it. Oops.
On the angle.
So my radius would be 2 root 5 root 20 or 2 root 5. And my angle, remember, that's always the one you want. This is always the angle starting here. But we'll find that one first. 63.4. So what do I put here for my theta in my polar form? 116.57. You okay with that? Let's practice going the other direction. What if you had to change 3CIS 12 into rectangular form, or cohesion form, or standard form, or complex form? What does that mean you need to find? X and Y. And when you find them, what will you do with them? How will you present your answer? Not as an ordered pair. It doesn't say find rectangular coordinates. It says rectangular or standard form, which will be X plus YI. If it says coordinates, you want an ordered pair. If it says form, you want something with an I in it. So either CIS or X plus YI, depending on which way you're going. All right, so how do I do this? How do I find the X and the Y that I need? I could draw a picture, but I don't need to draw a picture because what do I know X is?
3 cosine 12.
Yep, 3 cosine 12. So that would be 2.93 and 3 sine 12. Now you absolutely could draw a picture, so if that's going to help you, I don't want to discourage you from doing that. But it is completely unnecessary because when you find X and Y, because our cosine, our sine will always give you X and Y. Okay? Now, let's suppose we have a couple of complex numbers in trigonometric form. Your book names them, so I will name them the same way. Your book names them Z1, Z2, Z3. So let's say we have 3 CIS 110, and 4 CIS 87. And we want to multiply these two numbers together. Now the proof of this is actually really cool, but it takes a little bit of time that I don't want to use up on that. So you're just going to have to take my word for it. When we multiply two numbers in trigonometric form, let me just write down the answer and you see if you can figure out how I got it. That's the answer. I multiplied these two numbers. This would be the answer. How did that happen?
3 and 4 addition.
We multiplied the R values and then I added the thetas. That's it. That's all there is to it. So if I ask you, if I said Z sub 3 is 9 CIS 200 and Z sub 4 is 8 CIS 100, what would the product of these two numbers be?
72 CIS 300.
Perfect. Now, does anybody want to take a wild guess what Z sub 3 divided by Z sub 4 would be using these same two numbers? Anybody want to take a guess what the quotient would be? Okay, how did we multiply? What did we do when we multiplied? We multiplied the R's and added the angles. What do you think we might do in a division problem?
You're going to divide
Divide the R's and subtract the angles. Perfect. So if we wanted, come back to our original Z1 and Z2, if we wanted to divide these guys, the quotient would be 3/4, divide the r's, CIS, subtract the angles. Now, a little word of caution. I think you can see how it might happen that when you subtract the angles, you might end up negative. For example, in this problem, if I would have done Z4 over Z3, if I would have divided this by this, what would I have? 8/9, CIS, negative 100. Not allowed to be negative. So you have to replace that negative 100. Negative 100 is what you get. There's not a mistake there, but it's just not good form. So I have to replace the negative 100 with an angle that's the same as negative 100. So can you think of what that might be? 260. In other words, we need a coterminal angle. And how do we find coterminal angles? Add or subtract 360. Now, what also could happen is, if you had, let's say we had 8 CIS 300 and 9 CIS 200. And I multiplied those two. What would I get if I multiplied these? 72 CIS. Well, guess what? That's not good either. You're not allowed to have 500. You get 500, it's the right answer, but it's not good form. You would need to rewrite that as, you want to take a wild guess? 180. When you put a number into polar form, theta has to be between 0 and 360, or 0 and 2 pi if you're in radians. So if it's a negative, you're going to add 360 to get a positive angle. If it's bigger than 360, you're going to subtract 360 to get an angle between 0 and 360. Okay, now let's go back to the very last question on that quiz. I said we're going to come back to it. It says answer in polar form. And the problem is 3 CIS 50 cubed. Now you know how to do this.
Yeah.
You do. Because what does cubing mean?
Read that 3 times.
You're just multiplying it. We just talked about how we multiply. We are going to multiply this 3 times. And when we multiply, what do we do with the R values?
Multiply.
Multiply them. So that would give us
27.
27.
1.
What do we do with the R value, or excuse me, the theta values?
Add.
Add them. So that would give me 150?
Yeah.
And that's your answer, because it says answer in polar form. There it is. Now, thank goodness that was only a 3. Because I really don't want to have to write these things out like if that had been a 13 or something. I wonder if we can summarize that idea. Taking a look at the answer that you got. Go back to the original problem. This is the answer we got. Because essentially, we multiplied 3 times 3 times 3, which is 3 cubed. And then we added 50, 50, and 50, which is 3 times 50. So if I had a problem that was 2 CIS 10, let's say, and I wanted to raise it to the 8th power, what would that mean? 2 to the 8th, which is 256, times CIS 10 times 8, which is 80. What you just did was one of the most famous formulas or theorems in trigonometry.
That's it.
It's
Done it.
called
We're out.
DeMoivre's theorem.
3 quarters just flat out.
And DeMoivre's theorem says if you have a number in polar form and you are going to raise it to a power, then what do? You tell me. What's it say to do? R to the n. N times theta. That's exactly right. If you want to raise a number to a power, you raise the radius to the power, and you multiply the angle times the power. That's exactly what you did right here. You raise the radius to the power, you multiply the angle times the power. Now, why is this such a cool thing? Why am I so excited about this? Well, let's suppose that for some reason you needed to raise this number to the 5th power. Now, when you walked in the room today, you could have done that. You knew how to do this. You would write this parentheses out 5 times and you would start foiling. And it would take you a long time. But eventually you would get the answer. We just raised a number to the 8th power in about 3 seconds. Right?
Get it into the formula.
So the first thing I need to do, if I want to use this really fast procedure, the first thing I need to do with this number is what? Get it into trigonometric form. Because if I'm going to use DeMoivre, my number has to be in trigonometric form. So how do I do that? How do I change this into trigonometric form? Draw a picture. Here we go. I don't even need a calculator for this one. How big is this angle?
60.
60. So that would be 120. How long is my radius? 2. So this number is 2 CIS 120. Now I did that kind of fast. Some of us aren't paying much attention and we'll be hurting tomorrow if we have a quiz. Hint, hint.
She's still talking.
So I drew -1√3. My radius is 2. My angle is 120.
Then just put that
Now
5
I'm going to
down.
raise that to the 5th power.
Raise it.
Here we go. Takes 3 seconds. This to the 5th power would be what?
32.
2 to the 5th, which is 32. Is that going to be 600? Now, we got a problem with that. What's wrong with that?
It's too big.
Too big. So we'll rewrite it as 32 CIS
240.
240. Okay? Now, what if we were supposed to answer in the same form that we started with? Here's what I mean. This is complex form. This is polar form. What if I needed my answer in that form?
You just revert back.
I'd have to revert it back. And how do I revert this back? That means finding what? The x and the y. So x would be
Cos 32.
32 cosine 240, and y would be 32 sine 240. Now, if I have a calculator, that takes a split second. I can do this without a calculator, so I'm going to practice it. We haven't done this in a while. Because it's a 240, and 240 is special, what's the reference angle for 240, this angle right here? 60. So here's my root 3, here's my 1, here's my 2. So the cosine is negative 1/2, which gives me negative 16. And the sine is negative root 3 over 2, which is negative 16 root 3i. Remember, complex form is x plus yi. The calculator will do this for you and give you decimals. I did it by hand because we haven't done one in a while, and I think we need to refresh our memories a little bit. Can I do every problem by hand?
No.
No, only the ones that I rigged to be special. Okay? All right, let's do this. Let's, on your notes there, or scrap piece of paper you got laying around, let's answer a couple of questions here. Number 1.
It's really addicting. Sorry. Take it away.
What shape is that? Now this is just for practice, but I want you to see if you can start putting some of this together. What shape is that? It's one of the 4 classical curves, which by the way means it's either a rose, a limacon, a lemniscate, or a spiral, right? Which is it? Lemniscate. Kids, you cannot be confused. You will recognize the equation of a lemniscate because it's the only one that has a square. What is the shape of a lemniscate?
Infinity.
Figure 8, the infinity symbol. Yep, it's a figure 8. All right, next question. That's a rose. That is a rose. How many leaves does it have?
5.
5? Are they good with 5? How long are they?
8.
You're very good. Next question. Change into polar coordinates. Anybody else missing today? What did we come up with? Did you get it? What'd you get?
Root 13 and 213.6.
And when you wrote your answer, Tom Strife, I hope you wrote it like this.
Because they're
Right?
coordinates.
Because it says coordinates, and coordinates means ordered pair.
If you would have said polar form, it would have been root 13.
Yep. Yep. Okay, next question. And if you get this one, I will shut up.
Oh, man.
Pressure's on.
Now I want to get it wrong.
That was all.
Here's your question.
that takes some now. I'm doing lots of
Confusing myself.
Okay, Harry, you got an answer?
I'm doing it. I gonna have an answer in like 1 minute.
Do you change it into the rectangular form before you do before? You know what I'm saying?
I think I know what you're saying, but I'm not sure.
Never mind, I'll just wait.
Well, remember, we're raising a complex number to a power.
Yes.
So we want to use DeMoivre. Because our only other choice is foiling it. I don't want to foil.
So you do that and then you change it?
In order to use DeMoivre, it has to be in polar form,
Oh, okay.
right? Radius 2 power, angle times power.
Okay.
Yeah, so I would never want to change it in the rectangular form. Harry?
It's still coming. 1 second. Okay, I think I got it.
Okay.
Ooh, oh.
Answer is?
Oh, it. Which one's X, which one's Y? I got 2 numbers, not sure which one's X, which one's Y.
Well, how did you get the numbers?
It's some magic, some just deep,
What
dark
are the two
magic.
numbers you have?
3.32 and 15.38. Is that right, or is that just completely wrong?
Plus
I.
Yeah.
Or throw it in I.
I didn't get exactly.
I got negative 0.12 plus 15.
I'm not sure how you got those numbers.
I was spitting some dark magic at it.
I don't know.
Okay, well, the
It
magic
looked like he
didn't
was
quite
doing
work.
good stuff.
When we raise this to the 4th power, it will be 16 CIS 168. Would you agree with that?
Yes.
Because DeMoivre says radius 2 power, angle times power. This is the polar form answer. So if we were allowed to leave our answer in polar form, we would be done. That's it. But we want the rectangular form, or the complex form, or the standard form. So we want x plus yi. How do we find x? Always, always, always. X equals. Harry, you want to pay attention to this.
I'll
X
watch it. I'll
equals
watch it.
r cosine.
Ooh, but I don't mess with cosines.
So whatever you get when you do 16 cosine 168, which is negative 15.65, that's your x value.
I did not get that. How
Press
did you get
16 cosine 168. Did I copy it down wrong?
16.
Oh wait, we're still, I mean, we're still pretty much.
Yeah, we were.
I mean,
We
Oh,
were touching
I
that.
might be on radiant.
we went a lot longer out Mrs. Ford, but we got
Because
there.
168.
It's just because I don't mess with
I'm
cosines.
in radiant.
Yeah.
I'm good.
Put the foot down.
I put the foot down on cosine. That was bad. It's been great.
Alright, I'm good. Sorry.
And then our y value will be 16 sine 168.
What?
And that, if I did it right, is 3.3.
Yep.
Oh yeah, we got that. We got that.
money.
We got
It
it.
equals the same thing, right? If you put in 12 instead of 116.
You have to make it negative.
Oh.
I don't know why you would do that.
I don't know. When I did it, I plugged in the negative, but I just did it as a single triangle with the 12 degrees. And then
So it's
that-
negative 15.65
Yep,
plus
plus
3.33
We got that.
You just have to put it in the standard form.
Anybody have a question about this answer? This is the answer to that question. Everybody okay with that? All right, we got a couple of things
I thought
quickly
you
from
said
the
you stop
homework
talking if we got it.
that we need to clear up.
But that's just a
Tonight
big
we
old
will
fig.
practice a little bit with DeMoivre. I need you to look on the page. Let's see, page.
Yes, sir, but no,
Oh, it's just there?
Page 548. I'd like you to look at problem number 21 on 548. R equals 2 plus 3 cosine. Anybody know without graphing what shape that is? That's not a rose. That's a lima sign. Yep, that's a lima sign. A rose looks like this. It does not have a plus or a minus.
Lima sign does have a plus or minus.
We need to memorize this.
And then what's the one with the R squared?
Lemniscate.
A lemniscate.
Okay, so I'm going to go ahead and graph this equation on my calculator. I have no idea what my window is set as, so we'll see what happens. It's all messed up. Okay, so you hopefully got a nice little picture that looked like your lima bean. Looks like this. Now, the question says, identify the points where maximum R values occur. Now, what's R again, in terms of when I plot the points, what does the R represent? Okay, so here's the first circle. If you are on this first circle, how far away are you from the pole? If you're on the second circle, how far are you from the pole? And so on, right? So R is, how far are you from the pole? So polar distance. How far are you from the pole? So you are to look at the picture and figure out where is the point, or are the points, that are the furthest from the pole. I think it's pretty obvious there's only one in this problem that's the farthest. Now, what do I mean there could be more than one? Well, do you see that if you had a rose, there could be more than one point farthest from the pole? But with this shape, there's one. It's right there. Now, I'm not going to get all hung up on this. If you look at that graph, can you tell what the coordinates of that point are that's the farthest out there? 5. Isn't it 5, 0? And that makes perfectly good sense because what's the biggest cosine can be? 1. 1. So 2 plus 3 times 1, what is that? 5. That's why the maximum's at 5. Okay? This is not a huge deal to me, but that's how you do that. That's how you figure that out. Okay, so then the other thing I wanted to look at was, did anybody actually graph number 45? What did you notice? Did you notice anything when you graphed number 45?
Two little.
Yeah. Here's the deal. If we graphed 4 sine 2 theta, if we just graphed 4 sine 2 theta, how many leaves, this is a rose, How many leaves would this have? 4 leaves. And they would be how long? 4. Okay? Everybody's good with that. We've talked about that. Now, when we put a +2 into the problem, and they put it at the front, I was tacking it on the end, you still have a rose. But some things about the rose changed, right? What happened? It still has 4 leaves. But what about those leaves?
They got some booted.
2 of them are longer, and the other 2 are
You got some
shorter.
You got 0.
Now, any guess as to how much longer the 2 that are longer are?
2.
2.
Okay.
So now there's 2 leaves that are 6. And then the 2 that are shorter are 2. They all were 4 to start with. But when we stuck that +2 on there, it made 2 of them longer, 2 units longer, and it made 2 of them 2 units shorter. Do not memorize that. It's just an interesting thing. It's not anything to be all hung up about.
I think my calculator's broken.
No, it's never the calculator, Harry. It's always operating.
No, it's the
Okay,
calculator.
your homework is posted. Tomorrow you will be having a little quiz. Not a giant quiz, but kind of a quiz to make sure we're all where we're supposed to be.
Hats on the Big Bang look like sweet pig, man.
I mean, I read the book.
I do.